Halogenation. The halogens bromine and chlorine can add to alkenes, forming vicinal dihalides. Vicinal dihalides are compounds where the two halogens are present on adjacent carbons. Here is an example for the electrophilic addition of chlorine to an alkene. We have 2-methylpropene reacting with chlorine in the presence of dichloromethane to give vicinal dihalide. So this dichloromethane is simply going to act as a solvent, trying to dissolve both of these reactants. So the two chlorines are going to get added to the two sp2 carbons to form the vicinal dihalide. We might be thinking that this reaction may not be possible because we have electronegative atoms which cannot act as an electrophile. But in reality, this reaction is actually possible because the bond that is joining the two halogens is relatively weak and therefore can be easily broken, and also because bromine and as well as chlorine are polarizable. As the nucleophilic alkene approaches the bromine molecule, it's going to induce a dipole in bromine molecule, creating a partial positive charge on one of the bromines. And the other atom is going to have a partial negative charge. So these electrons are going to come in and the bromide ion is going to leave. So it is this electrophile that is going to get added to the sp2 carbon. Now, since the bromine's electron cloud is closer to the other sp2 carbon, it will try to form a bond with carbon, creating a cyclic bromonium ion intermediate. Once the cyclic bromonium ion is formed, it will then be attacked by this bromide ion nucleophile, and it will break open this highly strained three-membered ring, forming the vicinal dibromide. Halogenation is lead to the anti-addition product where the Br minus, which comes and attacks as a nucleophile, will come in a direction that's opposite to that of the three-membered ring structure. Here again, there will be no carbocation rearrangements because there is no carbocation that is formed in the reaction. The only intermediate that is formed here is cyclic halonium ion. Alkenes do not add to I2 because the product, the vicinal diiodide, is unstable and therefore it will always go back to the original starting materials.